Now we can understand that in a proper way. And to understand that, we must understand first of all the type of the coal. The type of the coal which we are using in thermal power station. One is called the peat. Another is called the lignite, then the bituminous, then the semi-anthracite, then the anthracite. So peat, lignite, bituminous, semi-anthracite and anthracite. These are the 5 types of coals which we are using in thermal power plants, and peat is the origin of the coal actually. So when the coal is actually in the process of the formation, and the peat is the very beginning of the coal, and the anthracite is the fully it become coal. So peat, and this is going like this only. First of all, the coal becomes peat, then it becomes lignite, then bituminous, then semi-anthracite and anthracite. Anthracite is the fully became coal, or the best type of the coal which is available. So this is also important in objective type of question, that the best type of the coal which is available for the thermal power plant, which will be increasing the efficiency, will be the anthracite of the coal, and the worst will be the peat. So in this way we can also discuss the same thing, that as we know that the anthracite is fully developed coal, and it is in the starting phase of developing peat. So if we are using anthracite in comparison to peat, our efficiency will be higher, because the per calorific value of this coal will be higher than the peat. So this will be giving more energy or more heat at the time of burning, when burning, as well as when it will be giving more heat, the more water will be heated up, more steam will be generated, more electricity will be generated. Whereas the peat will not be giving so much of heat, and that will be actually deteriorating the efficiency of the total thermal power station. Another thing comes which says that since peat is in the developing state, if we are carrying the same type of the coal to the same station, suppose if I am carrying 1000 kg of peat, and but obviously if I am carrying the same amount of anthracite, so anthracite, N-T-R-A and C-I-T, anthracite. So what obvious one can say that the anthracite will be giving more heat, so the efficiency of the anthracite is more. So if I say this thing, that if I am carrying now, suppose if I say that the peat is having 1/5 of the calorific value as the anthracite, so I can say that I have to carry 1000 kg of the anthracite to producing that much of heat, which peat will be given by 5000 kgs. So one can directly understand this thing, that when the transportation of the 1000 kg will be less, and the transportation of the 5000 kg will be more, wherever I am transferring this much of coal. If I am able to transfer 1000 kg of coal, which is of anthracite type, to the coal handling plant, at that time I'll be producing that much of electricity, which 5000 kg of the peat will be producing. This is just a understanding examples such that we can understand that how the transportation of the fuel changes the efficiency of the total power plant. So coming back to the discussion, that if I'm carrying 1000 kg of the anthracite to the station, or I'm getting the 5000 kg of the P to the station, and both are actually giving the same heat. So to take this thing, to take anthracite or to take 1000 kg of anthracite to the station would be cheaper than the carrying 5000 kg of the peat. So one thing which is very much important in case of thermal power station is the transportation of the fuel also, because 5000 kg will be transported at a higher cost, whereas 1000 kg will be transported at a lower cost. One more thing comes now, since anthracite is 1000 kg, and when it is stored in the storage plant, the cold storage plant, then it will be it will be taking actually the very less space. So the rest of the space which my actually coal handling plant will be having can be consumed by some more coal for my gestation period. Sorry, for my the period which where when my coal is going higher, the price of the coal is going higher, suppose, or the shortage of the coal, or for my reserve capacity, I can have the anthracite of coal when I'm using less coal with higher capacity. If I'm taking this to the coal storage plant, then what will happen? That it will be taking a lot of space. Apart from that, when it is coming to the coal handling plant, at that time also, to make this thing into pulverized, then I have to use more machinery, more time it would take, and lesser heat it would be producing. So the efficiency of my total thermal plant will be going down in case of peat if I'm using, and when I'm using anthracite, it will be going up. So after burning also, the anthracite will be producing less ash as compared to the peat. So the ash handling plant have to work more in case of peat, and in case of anthracite it will be working less. It's the same way ash storage will be working very much high. Ash handling plant is to work on a high capacity, because the ash handling would be much more difficult in case of peat, and in case of anthracite it will be low. So one can understand now how the transportation of the coal increases or decreases the efficiency of the total thermal power plant. One more thing comes in this, is now the type of the boilers. Types of the boiler also plays a very important role in the efficiency of the thermal power plant. There are two types of boilers which we are normally using in thermal power plants. One is called the pipe tube boilers, fire tube boilers, and another are called the water tube boilers. So we have fire tube, and another is called the water tube. So the difference between fire tube and water tube is name suggests, as the fire tube means the fire is in the tube and the rest of the part is surrounded by the water. In the case of water tube, water is actually in the tubes, whereas it is surrounded by the fire. So if I consider this is my boiler, and I have this tube over here and tube over here. So since I said that the fire is inside this boiler actually, and in case of the water tube boilers, I have water inside and the fire is outside. So water is inside this water is actually inside the tube and the fire is outside. So everything is surrounded by the fire. Here, as I said, that the tube is fire tube, so fire will be inside the tube actually, and everything is surrounded by the water. One can have the understanding while looking at this thing that red thing represents the fire, and the blue thing represents the water. So by just merely looking at these two type of boilers, one can say that since the fire is inside this tube, so the pressure inside the tube will be very much high, and they are likely to explode very easily. And one more thing, that since the this fire tubes are of the smaller cross section in comparison to the water, so they cannot meet the quick demands when the thermal power station is actually asking for. So they cannot meet the quick demand of the supply. Whereas one can see that the fire is outside and water is inside. So the quantity of the water in case of the water tube boilers are less. So at this time, the water gets quickly heated and it passes through the boiler. So the rotation of the water cycle in case of water tube boiler is higher, whereas in case of the fire tube boiler it is lower. So, but the fire tube boilers are compact in nature, but these are supposed to be very much big, so that the same amount of water is heated. So the pressure in this tube will be higher, and they are also they also are likely to explode. In case of the fire tube boilers, they are very much cheap. In the case of the water tube boiler, they are little bit expensive. So this is the difference between the type of the boilers which we are using, the fire tube and the water tube. So whatever is inside the tube is written over there. In the fire tube boilers, fire is in there, and in the water tube boiler, water is in there. Coming to another point which we have discussed in the hydropower plant, that is called the type of the generator which we are using. The type of generator we are using in the case of hydro generator are the hydro plants. Hydro generators. In case of the thermal power plant, we are using the turbo alternators. So we'll be using turbo alternator in case of thermal power plant. So they have, first of all, we can say that they are of high speed. They are of high speed because of the reason that they are having two poles only. And since they are of the higher speeds, we cannot use the silent pole of the rotor. We can use only the cylindrical type of rotor. And since the type of this rotor is cylindrical, so it is of smaller diameter. And since the diameter is small, so we can increase the axial length. Everything is related to everything. High speed because of the two poles, so they are called high speed turbo alternators. So speed will be higher only if it's having low number of poles. And since the speed is high, we cannot use again the silent pole of the rotor. We will be using non-silent pole, which is called a cylindrical type of rotors only. And since the rotor is cylindrical type, the diameter would be smaller. And since it is smaller, So we have to increase the length of the machine. So the turbo alternators are of the smaller cross section and the large axial lengths. So one should remember all these things when we are understanding the turbo alternators.